Here is
It says 27 and 28.
yeah.
Can?
Mm-hmm. Yes. Blood groups. Yes.
Yes.
Mm-hmm. Oh, yes. Also takes platelets. Yes, three. Here is three chapters. Yes.
3 chapters.
Yes, here in this book. Yes, in this book 2 chapters. Yes. Okay. Blood types. In some cases there is necessary transfuse blood from one person. Each person is called donor usually. To other person is called recipients. Yes. But for such transfusion, we have to know blood types, group of blood. Yes. This is just introductory picture show you this blood types. Yes. In the beginning of 20th century, two scientists, it was Czech physiologist Jan Jansky, four groups of blood, and they called group number 1, 2nd, 3rd, 4th. This is historical, because for that period of time they did not know about we know now from immunology antigens, antibodies, but experimentally they checked the blood usually and discovered so there is 4 types of blood.
Yes,
in some
yes.
cases, transfusion is successful, but sometimes it's
Not
they
successful.
have lethal effects in humans.
Between different blood groups.
Yes. So, and later, Jan Jansky died more young, age, and later it was 1930. Then Landsteiner and his young colleague Wiener, they discovered other type of antigen. They called them rhesus factor, rhesus. So they got Nobel Prize. It was 1930. So and then.
So both O and A are same.
Yes, I say it. I got Nobel Prize, and Landsteiner discovered like antigens and antibodies like such factors here in blood, in erythrocytes. They call these agglutinogens. So this process is called agglutination. So these factors that in erythrocytes, one type of they call agglutinogens, and then discovered 2 types agglutinogens, A and B, but in plasma later they discovered like antibodies in plasma. So they call them agglutinins. Maybe more or less you know about it. So later he introduced new classification, like 1, 2. New one is like OAB, system of classification of blood types. So it means when we in erythrocytes we have no agglutinogens, so we have no agglutinogens. But when we have no agglutinogens, we have agglutinins. So this called usually like anti-A, and here is anti-B. Both now are present in the plasma. In some classification, it's same like alpha and beta. Alpha and beta. Yes. So for one group here, we have no agglutinogens. If we have no agglutinogens, we have both agglutinins, because when they meet to each other, we have agglutination. Yes. This is reason of lethal effects in transfusion usually, if we transfuse much amount of blood, but not a small amount like, for example, 500 milliliters.
It is small.
Small amount, 500 milliliters. Because such amount usually dissolved in 5 liters in the blood.
Yes.
In blood, it's so not so dangerous. But if we transfuse more 1 liters, it's dangerous. Such situations. Yes. Other groups, group A group. A group means so A agglutinogenes is present in erythrocytes. RBC here, yes, but no B. If no B, so in plasma presents anti-B agglutinins.
Anti-B.
Yes, yes, it's not dangerous. It's yes. Contrary for group number B, so for this group, so we have B agglutinins, no A, but we have anti-A.
Yes.
Yes, contrary to this group A group. And the last one, so it's called AB group. So when we have both agglutinogens, but no presence in the plasma agglutinins. Agglutinins.
Sir, what is agglutinogens?
Agglutinogens, they are around erythrocytes, like proteins, agglutinogens. This is like immune cells, like antigens. Antigens. Antigens, yes.
And what is
like antibodies, agglutinins. This is like immune reaction between them.
Agglutinins are present in the blood, like free from, freely flowing.
Agglutinogens usually are on the surface of erythrocytes. Erythrocytes bind them usually. Such types agglutinogens. But in plasma we have agglutinins like immunoglobulins. Like immunoglobulins types, one of types of immunoglobulins. Agglutinins, yes. So here in this picture from other book showing more or less here you can see here agglutinogens, for example, A, like this one is small balls, this one here. So for group A, so we have such agglutinogens, this one here, but in the plasma at the same time we have anti-B, yes, anti-B, no anti-A, yes, good, understand. For group B now, we have other types of agglutinogens. Here, like square here, is like ball, small ball. Here, this one. Here, yes, this one. This on the surface, these erythrocytes, RBC, and now in the plasma we have anti-A. Yes, contrary to each other. Yes. Then group AB. So when we have on the erythrocytes, we have both types agglutinogens. Is this one like balls and square here? Both and no agglutinins here in the plasma. And the last one, group O here. So you can see here, absolutely absent. Absolutely absent. Agglutinogens, but presence both types of agglutinins. This one and this one. Yes. So usually in population group number O, so when we have no agglutinogens but we have both agglutinins, this is most popular group of blood. This is population. White people, this is 47%, and second one is A group, 41. So most of population, white race population, white people. So usually first to one is most popular. I get one.
Hey, India is same.
India same, yes. Okay.
Yes.
For example, for African people, this is a little bit more. It's little bit more.
First group?
First group, yes, in African race. Yes.
Most popular group it is
O group.
O group.
O group, yes. O group is the yes. And this one is lesser one, much lesser one.
And lesser one in the just Caucasus people like they're
Caucasian people, this is like white people. This is same, yes. Yes, these graphic show you now distribution of now agglutinins. Agglutinins, so anti-A agglutinins, for example, mostly are in the group B and O group blood, and you can see here is also are more than agglutinin A in the group A and O blood groups here. Also interesting phenomena is here, so you can see with aging and when people is are older, so you can see this is also decrease. Decrease. You remember with aging also usually production of RBC usually decline.
Yes.
Here is also decline, so easy. So it's also emphasized. So early stage of development of people, a child, is most important of these cells also, like RBC, other blood cells also, these immune cells for blood groups. Yes. This is show you situation when, for example, meet blood donors and recipients. For example, experimentally when we have in sera anti-A, anti-B agglutinins and agglutinin genes in the other blood for donors, for example, and in which cases we have agglutination. So for this situation we have no agglutination because here is agglutinogenes and here is just agglutinins, no problem, yes? But then when we transfuse, for example, group number A and in sera is presence for example anti-A, yes, we have such reactions, agglutinations, yes. And when it's just B, no. Contrary, B now it's when it's meet anti-B, so we have again agglutination.
AB
and
both.
last one when we transfuse AB and both, so it's much higher is agglutinations.
Yes.
Yes, both class we here because both agglutinogens meet both agglutinins in the sera. So this process is agglutinations. Yes, this picture show you also more or less nice picture show you these blood groups, but also other factors like rhesus factors. Yes, Landsteiner and Wiener. Then in monkey, rhesus monkey, they discovered this factor. Also, this is like agglutinogene. This is also agglutinogene. Some people, for example, 85% of globe human population usually presents this factor. Rhesus factor now is called, and just 15% is absent. So some people, most people are rhesus positive people because presence of this factor rhesus, and just 15 this is absent of this factor. So you can see here these groups with presence of here is absent of rhesus factor. So this is one green small green, and this agglutinogens here bind of erythrocytes. This is agglutinogens A, agglutinogens B, both agglutinogens, but absent or no factor. Yes, no rhesus factor. And these four groups with presence with same but presence with rhesus factors here. Yes.
AB negative is really rare.
Yes.
Because of this.
Yes. Okay. And why is dangerous of rhesus factor? Rhesus factor especially is dangerous for pregnant women.
Yeah.
Usually we have to, it's called check or typing of blood for recipients, and we have to know what groups is donor, what groups is recipient, and is presence of rhesus and no. We have to know if we transfuse rhesus factors the blood to no rhesus factors human. Yes, it's dangerous. Such a conflict is called rhesus conflict we have between mother and fetus, a baby. Here, this show you. So dangerous. When is dangerous? When mother is negative. So absent of rhesus factor.
What's happening now?
What happened? Yes. What happened now? When fetus maturates and then later, so usually it needs several months, and then you can see here usually when in the fetus is positive, inherited from father. Yes, father is rhesus positive, and child may be also rhesus positive. For example, here, and mother is negative, absent of rhesus factor. Then this fetus produce positive agglutinogens like rhesus factor. Mother start production like anti-rhesus factor agglutinase, anti to this plus anti. So these like antibodies now move to the fetus and agglutinates fetus blood, because meet here in the fetus blood meet these agglutinogens, rhesus factor, and so we have agglutination. It's dangerous for fetus. Fetus at the last, especially at the last stages of pregnancy, because first of all, summer period needs for maturation of fetus baby, and then also for production these antibodies. This is also need 3-4 months. Yes, for production this much amount of antibodies. So that's why this dangerous about pregnancy 7 months, 8 months, 9 months for child. Yes, but sometimes it's not dangerous, but much dangerous for the second pregnancy. If second baby for this mother, second baby again from father, again rhesus positive. Now as a classic immunization reaction. Secondary immune response is much higher, 100 times more production of antibodies. Like here, also much dangerous is for the second pregnancy, second child. So that's why usually such mothers birth just one child. But now there are some special depressors, yes, medications they take, and they should be take care about second pregnancy, especially second pregnancy. Yes, yes. So usually recommendation is for girls. So should know if you are rhesus negative. For example, yes, if you are rhesus negative, you should ask your boyfriend or your husband and know is he rhesus positive or rhesus negative. You should find for you rhesus negative. If you are rhesus negative, better for you Ask him, is he or negative or positive? If negative, it's much better for you. For example, if you are negative. If positive, should we take care? Yes, and monitoring of your pregnancy. Yes, go to clinic and be under monitoring of your pregnancy.
Teacher, what
Yes.
about when it is child is negative and woman is positive?
Yes.
The same
yes.
or not?
No, this no problem.
No problem.
If yes, if mother,
Good question.
yeah, is no problem. Why? Because when mother is positive and child is negative, so child do not produce
Antibodies.
do not produce against mother. So for mother is no problem because mother have usually 5 liter blood and fetus is very small
Yes.
now, absolutely blood circulation very small, and this small amount it's no problem for mother.
But also-
so it is no conflict in this situation.
But also we can say that we are saying that we can transport positive blood to the negative. It is no problem.
No.
When we are giving blood example, I have positive blood too, and you have negative.
If you yes, if transfuse rhesus positive blood to the rhesus negative, this is rhesus positive blood to rhesus negative. This is
Yeah.
problem, yes, because such blood have no effects because recipient start production antibodies. So such blood no effect. Transfusion effect then is zero. So should be no. Usually now the recommendation is so every people should be every people should be absolutely same blood.
Group, same blood.
Yes,
Yes.
O group,
Recommendation
and
now
same.
like this.
O positive
Yes.
is O positive.
Yes.
Now example, one can't give.
Yes.
Yeah.
Okay.
Which I heard this universal donor and
Yes,
universal.
it's usually it's called, for example, in this situation, usually, for example, it's called universal donor, but it's all classification. Yes, O group usually called before universal donor.
Universal donor.
And this one,
Acceptor.
yes, universal acceptor, universal recipient, yes. And for example, if you put this blood transfuse this group here, so usually when it's a small amount, usually this is about 500 milliliters. 500 milliliters. Usually this 500 milliliters dissolved is amount 5 liters. It's no big problem, no big problem. But if we transfuse more, it's then dangerous. 1 liter, 2 liters, for example, in some accidental situations, this is problem. But usually now recommendation absolutely same.
Yes,
O to O, A to A, B to B. Yes. Okay. Yes, and now second, blood coagulation. Blood coagulation.
10 minutes.
This is blood coagulation. It's also important defensive mechanism to keep at the constant level for blood 5 liters blood. So this is interesting also mechanism, special mechanism, blood coagulation. So when we rupture any blood vessels, capillaries, so on, we have 4 reactions. First one is vascular constriction, because usually here is released some special substances and contract smooth mass in blood vessels to reduce or hold in the vessel. Yes. Second one, formation of platelet plaque by mast cells, platelet cells. And third reactions is formation blood clot by mechanism by blood coagulation. So we have more than dozen factors, special factors in the blood. Mostly are proteins. And last one is low fibrosis tissue from fibrinogen, and formation last stage of blood clot. Yes, so you can see here. So when we rupture here, you can see here. So especially this is, for example, big blood vessel and higher is arterial pressure. So first reaction is formation after constriction. Here we have agglutinase and by platelets and try to form platelets plaque, but then is not enough for stop bleeding here. By these mast cells, platelet cells, thrombocytes, here is yes, RBCs, and so formates such platelet aggregation here and stop bleeding. Yes, but for big blood vessels it's not enough, so we have, you can see here, many such factors here. Factor 1 is fibrinogen, but this is just chronologically, these when factors are discovered, not importance. Importance is, first of all, is calcium ions, but his number is 4.
Yes.
But calcium ions is the most important factor for coagulation. And then also other prothrombin is also, and then fibrinogen, yes, tissue factors is thromboplastin, tissue and blood thromboplastin.
These
so
four main important, yes?
Yes, yes. These first 4 are the most important, especially calcium ions. I show you next pictures. So this is stages of such coagulation. Usually, this is generally, we have such cascade of reactions, different stage. At the first stage, usually formation prothrombin activated. Then prothrombin activator helps to form prothrombin into thrombin, transformation prothrombin into thrombin. All of them like enzymes and helps of these reactions. And then thrombin as a like enzymes also transform fibrinogen into fibrin. Firstly, fibrin primary is fibrin monomer, and then we have fibrin polymer. Formation forms fibrin tissue like mesh, and into these tissue fibrin fibers then stopped all blood cells, especially red blood cells. So with such form of clot here. Next picture I show you. But this cascade of reactions is developed by 2 mechanisms, more or less parallel mechanisms. First one is it's called extrinsic pathway, and second one intrinsic pathway. Why it's called extrinsic? Because this process starts with a rupture of blood vessels, and then blood vessels stimulates this cascade of reactions. So this tissue, this called tissue thromboplastin. So tissue thromboplastin are start for this one is called tissue factor, and then tissue factor activates. This is numbering of these coagulation factors. A means activated. Yes. So first of all, factor number 7 are activated here.
We have to remember that factor we studied before, the calcium, the prothrombin.
Yes, here, yes, all of them here, yes. These factors, factor 7,
serum prothrombin.
Yes, prothrombin conversion accelerated. Yes, so all these factors, then here, then is activated number 10, now activated 10th A here. So last one finally is formation prothrombin activated. After all these cascade reactions, prothrombin activated, and then prothrombin activated, prothrombin transformed into thrombin. Yes, but you can see here so important is calcium,
Four.
because almost all stages, all these reactions, presence of calcium ions is
vital,
most
yes.
important. Here is calcium, for example, here
Here
is
is also.
calcium. Everything is calcium, yes. So, and second factor is more or less complicated, more reactions and more factors are here involved. This is blood thromboplastin. So here is mast cells, thrombocytes are involved. That's why it's called.
The last one we studied
blood
was
Initiated.
Yes. So at the last stage, all this, after this, all this transformation of this, so many factors, also presence of calcium ion are important here. So also platelet phospholipids are involved here. So calcium. So last net product of
Prothrombin activated,
prothrombin
yes.
activated.
Prothrombin
So
changing to
these two
thrombin.
parallel pathways come into formation
Of a blood clot.
prothrombin,
Two
yes,
thrombin,
prothrombin activated, and then prothrombin activated, transformed
And
into
everywhere
thrombin,
calcium
also
important.
calcium. So you can see this at the last stage. So prothrombin activated form thrombin, and then thrombin helps fibrinogen.
fibrinogen.
Now, yes,
Ah.
now involved fibrinogen. Fibrinogen now transformed into fibrinogen monomer,
Monomer.
and also here is next calcium,
Ah.
and then form fibrin fibers like cloth,
Mesh-like
yes,
mesh. Yes,
mesh fibers here, fibrin, and then we have
Cross-linked fibrin fibers.
many as like mesh, and between these fibrin fibers stopped here many blood cells. That's why clot usually is a red color.
Yeah,
red
yes.
color because much of erythrocytes are here stopped, and the later is become more darker.
Yeah. What is it after this?
retraction.
Retraction.
After retraction and released, as I told you, serum. What is it? Serum.
Serum.
This is same plasma, but without all these
without
factors. Without all these factors and without fibrinogen, all these dozen of factors. Yes. That's why such serum can't coagulate. Can't coagulate because all factors now are in the clot, in the blood clot. And then at the last stage start other after retraction start now elimination of clot, other in the blood factors like enzymes, plasminogen, firstly plasminogen transformed into plasmin, and plasmin start digest of clot.
Plasmin digestive clot.
Yes, and then after reparation of this hole, then this is clot remove about 1 month. It depends on how
it is,
bigger or small.
Most important thing, calcium.
So you can see at this picture also from other book these stages of blood coagulation. So at the first stage, platelet cells are here, and then bind of blood vessels wall, and then form of fibrin fibers here, like then finally this is fibrin fibers, and these fibrin fibers like mesh. So stopped here many RBC here, and completely seal the hole in the endothelium of this blood vessel, and stop bleeding. Okay, so please prepare all these 2 chapters.
Thanks, teacher.